Hello everyone, this is Bradley. So today this is a tutorial talking about the weave animation that I've done in the past. The most initially I did that because people were asking a static weaved tube design. So I was trying different methods that I failed. This was, technically speaking, a failure for the question, but I end up just modifying that into an animation. So that's what you're looking at. So the recording didn't really cover the part I converted the setup into an animation. That's why people asked, and here I'm making this tutorial. So let's start. So here we're in Blender. As always, I'm going to use the presets, which you can download for free from the link in the description. Let's create an object in geometry node tree and use the curve linear, okay, which by default is just a curve line on x-axis being centered. Okay. Just briefly discuss the step and the stop. This is not really a new concept because you can see exactly the same concept within mesh line. So the offset is the step mode, the endpoint are the stop mode, which means there are 10 points in total. So if you are in the stop mode, which means you are not checking this box, it means there from the start to the end, the length is 2, and there are 10 points in total. But if you use the step mode, which means from points to points inside, the interval is 2. Okay. In this case, I'm just going to use the step mode, but I would like to keep these values to be small, so that if I increase the count, then it will lengthen the total length. Okay. And then I'm going to point an instance yet. Before point instance, I also would like to discuss the change of this XYZ. So from 0, 1, 2, it means X, Y, and Z. Okay, so I would like to make these lines working on the y-axis. So this is how it looks. So now if I'm instancing another curve line on the Z x-axis, then this is how it looks. Okay, so you can increase the value or whatever. Okay, so right now I would like to do a realize instance because I would like to access all these kind of vertices and then use the setup position. I would like to basically do a sine function. So let's take an XYZ on the offset and use a sine function node to manipulate on the z-axis. So immediately there is no effect, but if you change this value, you can see this entire geometry is moving up and down due to this sine wave. I would like to have this sine wave working on each vertices differently. So I'm using the position x values, so separate x, y, z, as a trigger of this sine function. So immediately you can see there is an up and down movement. And if you increase the frequency, then you can immediately see this sine wave. There is an issue that we do not have enough resolution. That's why it's not looking very smoothly. So in this case, because we're using the step mode, so the only way to increase the resolution is to decrease the value. Okay. And then you increase the length by increasing the count. Okay. So this is what we are looking at for the moment. Okay. We have a smooth sine wave. I personally do not really like the pattern of a sine wave because it's a predetermined pattern. Okay. And to change the pattern, you can definitely use the float curve node. But there is a lot of issue. For example, it by default is clipping that to 0 and 1, while the sine function is from -1 to +1. Okay. Of course, you can change with the amplitude, but in this case, I'm just going to remap 0 to 1 so that I can manipulate this kind of patterns. But on the other hand, because this sine function is already a curved pattern, so that's even if you use the float curve, it's not a visually easy to understand. So in this case, I'm going to switch that to the linear. The mechanism for the sine function into a linear function is instead of using the sine function within this method, where's my sine function? Yes. Instead of using sine or cosine function, I'm using the ping pong. Okay. So this is basically a linear sine function. So right now, after linear and remap to 0 to 1, so we can manipulate this float curve more easily. So if you just crush these 2 points with your handles, then you get this kind of straight patterns, and we can remap that to negative and positive using the map range. So here I'm going to take a negative so that I use a single value to control the output minimum and output maximum. So by increasing this original, you can see it expand up and down with the same amplitude. Okay. So this is the pattern that we're getting, which is cool. And we're instancing that on different axes. So this is how it looks right now. You can decrease the count or increase the step. Okay. Next, I'm going to duplicate this group and rotate that by 90 degrees so that I have this kind of interlacing pattern. This is just a example. I'm going to duplicate everything within geometry node tree. So here what I'm going to do is to duplicate everything related to this set position by making them into a group node. So that instead of duplicating this entire node tree, I'm just going to duplicate a group node instead. So select all this kind of node and hit Ctrl G so that they're in a group node. Okay. Within this group node, I'm going to change several things. One is I'm going to change the sine wave into the cosine wave so that the middle point is always a full full amplitude up and a full amplitude down. Okay. So this is kind of important as we will discuss later, because this center point will be the reference point as we are doing the deformation. Okay. And I also would like to output two kind of value. One is the phase. Another is the amplitude. But this amplitude is very meaningless. The actual amplitude that we are deform this sine function is actually the one from this negative. So let's just output this original to the input and name that as amplitude. Okay. So once we have this group node, let's just name that as a weave unit. Okay. And we have our group outputs. So this node tree becomes much needed because there are only 5 nodes in total. Here I'm going to duplicate these group nodes and join geometry. Immediately we do not see any new things happening because these are overlapping geometry. But we can distinguish them by using a transform node and rotating 90 degrees. So immediately we can actually see these kind of changes. We have these kind of interlacing patterns being generated. To better visualize everything, I'm going to use the bevel curve and decrease the radius a little bit. Okay. I think this, although this comes a little bit accident, but I think this is already a good pattern with all these kind of values. The only issue that we are realizing is that when the horizontal line is up, the vertical line is also up. So they are intersecting to each other. So instead of actually a good weaved pattern, it's kind of something's wrong. Okay. So in this case, I'm just going to increase the phase by pi. This is the difference between sine function and cosine function, so that when the sine function is full amplitude up, the other one is full amplitude down. So this is just kind of difference. And essentially you can change all these kind of parameters that align differently. Previously I mentioned I need to use the cosine function within the node group because I always want this full up and down as a reference point in the center. Okay. So let's go back to 0.72 because we always have a line intersecting to each other. Next, I'm going to make this entire pattern more dense. Currently, we do have an issue that we always have this kind of hole in between. Okay. To fill this hole, we basically, again, are going to duplicate this geometry. So we basically use the same method using the join geometry. And I'm going to use another transform node. This time, instead of using the rotation, we're going to translate it from towards the right upper side. So now we fill this entire pattern. Okay. I do not know the mathematical correct numbers, and I do not want to do the calculation. You can potentially do the calculation by your own by calculating, I guess, whatever things that's related to all these kind of values. Okay, but I have no idea at this moment. I'm just going to do the brute force, and it looks kind of pretty nice. Just to make sure this kind of number change are the same, I'm just going to use the combine XYZ and we use an value. Previously, we already know that 0.33 is the value that we are going with, and this looks kind of nice. Okay. Another thing we're going to do is to make this kind of pattern more dense. Okay. So mostly initially we're instancing this line. Okay. And I'm going to instance this line again with a smaller amplitude. So what I'm going to do is just to add another curvilinear to set the value to be 0.01, so that basically there is no difference, but you can see this kind of thin line being generated, right? And let's decrease the count. Okay. So finally it goes back to the last. We do not see anything obvious, but if you increase this value, you can see how it has been changed. And this count is completely procedural. So initially you have 1, 2, 3, 4, 5. So finally you end up with this pattern, okay, like a weave structure. This is completely procedural. Everything is completely procedural. Okay. And this is for a static pattern, this is basically done. The rest is just tweaking values, because I always feel that this amplitude is actually too high. So you may want to use a smaller amplitude or other things. Okay. But there's other things we would like to do is the animation. The animation part is pretty straightforward. There are essentially two parts. One is to cut. The other is to changing this amplitude, because if you're increasing this amplitude, then you have this larger, larger elevation. And I would like to make kind of a gradation effect that it starts with a large elevation and then it decreases itself. Okay, you will see the effect later. Okay, to achieve all this kind of effect, we need a falloff, which is, you can also think of that as a mask. In this particular case, I'm just going to use the directional falloff, and let's just see kind of effects when we plug that into the amplitude. And immediately you can actually see an effect that the part of this sine function has a high amplitude, the other part has a extremely low amplitude. And this is the effect that I'm looking for. It will be better if we use an object to control this directional falloff. So let's add an empty. So let's here we're using the empty as a controller. Okay. So that by moving that we have this effect. I think I'm going to reverse this effect. So let's take an map range. By default, the output is 0 to 1. So we just reverse it to from 0 to 1 to 2 to 0. Okay. Yes, something like that. So let's increase a little bit. So we keep the minimal effects. So we have an effect like this. It may not be very obvious about what we are trying to do. So finally, this comes to the second part. I'm going to eliminate all the rest of the parts which has a high amplitude. Okay. So in this case, you may think I'm going to use the trim curve. It's definitely possible. If you use the trim curve, then you trim a lot of parts of that. Okay. But to use the trim curve, it will disrupt the UV that we are going to manipulate later. Okay. So I'm not going to use the trim curve. Instead, I'm going to use the set curve radius to mimic a kind of the effect. And let's plug the falloff into the radius. So here we can see there is a tiny bit of radius which is between 1 to 0 or 0 to 1. I'm going to eliminate this transition by using a color ramp, setting it to the constant, and just crush this constant value so that we can see there are regions which has a high amplitude. Okay. So this is what we get. So now we can see this kind of growing and trying to knitting itself. Basically, this is the effect that we're going with. Okay. So this is just an example. In details, you can play more about this kind of a setup. For example, dealing with this kind of weave unit, or this kind of interpolation within the float curve, sine functions, and so on, and all this kind of amplitude. At last, within geometry nodes, I would like to add some noise. because right now every of these cutting are completely straight due to the characteristic of directional Falloff. Okay. So I would like to add some randomness in the position attribute, which is used for this evaluation. Okay. So to do that, as I've discussed in the netting tutorial, it's basically you need a random value per spline instead of per point. Okay. So otherwise, if we use a translate position, this node looks kind of very complicated, but in reality, especially in this particular case, it's basically just a vector mass node adding the position. There's nothing really special for that. It's just stacking the vector mass for the multiply, scale, and combine x, y, z, and so on and so forth. Okay. In this case, let's just use this vector plugin into that, and by translating the x and y, you can see this kind of because we're changing the way of the evaluation, so the directional Falloff doesn't really match the effect upon translation. So here we're just adding a random value. If we directly adding this random value to the x value, then you can see this is kind of jagginess, because the random value is applied to every index or every point on our setup. This is not really desired, so we need to have a random value per spline in which we're going to have an attribute spline. This attribute spline node is generally speaking just a capture attribute on the spline domain, whether you capture an index or capture a vector on vector domain or something like that. Okay. So in this case, let's just take this index per spline to the ID, then immediately you can see there's a nice random value being generated for each of them. So we remove all this kind of previous jagginess and so on. Okay. But on the other hand, you need to realize that this from random value to random value, there's no relationship. Okay. So if you want to have some relationship, you may want to use noise texture. Okay. And you can potentially plug this position into the vector and plug the factor into the place. So if you increase the scale, which is essentially the frequency of your noise, then it can be more jaggy, or if it's 0.1, you can even see this kind of patterns of wavings due to this smoothness of noise and so on and so forth. These are just the kind of concepts. So whichever way you prefer or whichever thing you would like to do, it's completely up to you. Okay. So after we finish this, finally we goes to the material things. So here what we need to do is just to output this UV as I've explained within UV tutorial. So let's just type in UV. Okay, and we need to add a material. Let's set a material, add a material, set a material. So finally, let's go to the shader tab, and let's edit this material. So we need to import, so for the moment I'm just going to use the emission shader for convenience. And let's take an attribute, take the UV, take a vector for the wave texture, and take the color. So if I go to the material preview, so this is the setup we get immediately. Let's go with the wave on y-axis. So it's kind of very ugly right now. It's just a decreased scale. Okay. So something that looks like this. I think this is already kind of good at some level, but I would like to twist it a little bit. So here, let's add a vector mass. One thing I want to remind you is that all this kind of UV by default is constructed based on the curve parameter. In 3.1, it's called the spline parameter. Okay, I've explained all these kind of things, which means from the start to the end of this entire UV is 0 to 1. This is a very short range, so I'm going to switch that to length. You do not really see immediate difference if you switch that to length, but you will see kind of difference once you trying to use the vector rotate. And let's try to use the Euler as rotation. I do not know which axis you should rotate. X seems not really working. Y not really working. But if you use the Z, yeah, it seems working. So you start to have kind of a twisting effect going on. Okay. So you can see there's kind of a wave being generated. It's still not very obvious. So let's just take a vector mass and multiply 1, 1, 1. And if we multiply on X, then immediately you can see this kind of waved patterns, how this texture is being going through. This is just the kind of way of thinking. It's not a mandatory. So you can decide by yourself how you want to deal with this kind of texture and so on. Okay. Definitely there's tons of ways of doing that. It's none of these are mandatory. These are really just the concept. So if now we play this animation, I think oh, you probably do not want to use the length, because once we're deforming the spline, the length will change, so that the UV will change. So let's go back to start with use the factor, and by increasing the factor, so now we have a more static UV, I hope. Or potentially we can use the index. I don't know, I finally, depending on the render results. Actually, this looks kind of so ugly that I cannot really determine if it's good or bad. But I believe there must be a way which will essentially satisfy you. If you encounter other issues, because as I've explained in the tutorial, that because this is a cyclic spline, sometimes you will have this kind of border which contains error. So in this case, you just reset the cyclic, remove this kind of thing. Okay. So these are just the kind of idea you can deal with by yourself, and finally, it's just the kind of issue of all these kind of parameters. You can decrease, increase this kind of parameters, make it more square-like. So this is the basic part of this animation. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.